Hello, a quick video explanation of standard deviation, what it is. We all know about means, and mean gives us a focus on what the central tendency is. What we need is something that will measure spread, and that's what we're going to get from our standard deviation. Quick example, we're taking measuring sticks from a tree that have fallen from a tree, say many centimeters long. We've got our first list. We get 9 sticks and they're all 5 centimeters long. In our second group that we pick up, they range in length from 1 to 9 centimeters long. Looking at our first list here, we can see that every one of these sticks is 5 centimeters long. We've got 9 of them. So our distribution is very narrow, isn't it? In fact, it's got a single value. So we know the mean's 5. But compare that to this the second list here, where we've got all 9, but they range from 1 to 9 in length. They've still got an average. Our mean is 5 for both of these, but this one is very spread out, and this one has no spread. The one above has effectively no spread on it. So we need a measure of spread. We've got a measure for the mean. Now we need a measure of spread. So how do we calculate the mean? Well, the mean is calculated as the total length. So we find all of those, add them up to 45, and then we share it equally out over all the number of sticks counted, which in this case was 9. So we now need to look at a measure of spread. What is a suitable measure? Let's have a look at an example. We're particularly interested here. One of our sticks was 2 centimeters long. We know our mean was 5. So what we were interested in is measuring the distance it is away from our mean. In this case, it's -3 from our mean. But we want to avoid getting into any confusion, because we're not really worried whether that was, if we looked at our number 8, our stick that's 8 long, that would be +3, but they're both 3 away from the center. And our way of overcoming this is we're going to calculate each one of these as the deviation. Yeah, we're going to calculate the square of the deviation. So for our first one here, a stick of length 2 is its deviation is -3, and we're going to square it to get rid of the sign, and that will give us 9. Then we're going to sum up all these squares. So we've got 9 sticks, each one's going to have a square. Then we're going to share them out equally by dividing by the total number, as we do in a mean. And then our problem is that the value we've got now is in centimeters squared, so we need to square root it to get it back to the right units, in this case centimeters. Yeah, can you see that what we've done is we followed the same approach that we do with the mean? Calculate the values, we sum them, we share them out equally, and then we've got our correction here, the square root part. Okay, so given what we've said there, so I just want to be clear here, it's why some people often call the standard deviation the root of the mean square deviation, because that's what we did, wasn't it? We found our deviation, we squared it, we found the mean, and we rooted it. And that's sometimes called RMSD by people. Okay, let's have a worked example then. Let's have a look at our list 2. We know what our values are. They went from 1 to 9. We can then calculate the deviation for each point from the mean. So the length of 1 is -4 away from our mean of 5. We then square it to get 16. We can do the same thing for the stick that's 2 long, that's centimeters long, so that's -3 from our norm, and so when that's squared it's 9. And similarly at the other end here, with our stick that's 8 long, it's +3, we square it, we get 9. We then sum all those squares, there we are, they're all the values from above, and we get a total of 60. We then want to find the mean value of those squares for each of the 9 sticks. So we take our 60 and we divide it by 9, and we've got 6.66 recurring. And finally, we're going to find the root to bring it back to centimeters. So we do the square root of 6.6, and we get 2.58. So Our two core statistics for list 2 are a mean of 5 centimeters and a standard deviation, that RMSD we've just calculated, of 2.58. That would describe that distribution. Let's have a look at the first list. Well, all the values was 5, weren't they? So their deviations from the mean are 0 all the way down. So the sum of the squares here is 0. So the mean of those squares is 0 divided by 9 is 0, and then we're going to root it, and again we're going to end up with 0. So if we want to describe list 1, well, again our mean is 5 centimeters, but our standard deviation, the RMSD, is 0 centimeters. So there we have it. We now have a standard deviation which is a measure of spread, in the same way that a mean is a measure of the central tendency. And our standard deviation, it can be calculated from the root of the mean and the square deviation, which in practice we calculate by calculating the deviations, squaring them, finding the mean of them, and then finding the root. Hope that's of use. Bye.